All right, so now back to our regular math book. So this is lesson 1.2. Now, previous lesson was 1.1a in that in success book, right? And that was on primes and composites. So we have to learn what a prime is, and that these numbers ideally are going to be composite numbers. So we're going to break them down into all of their primes. There are two different ways that the book shows us to do it. I find that this is the easiest way and the more systematic way to build it. Notice it's kind of offset. That's a little different than the way the book shows it, and I'll talk about that as we work through it. Okay? This way looks kind of odd, but all that is, it's called inverted division, and inverted just means it's flipped upside down. If you would turn your book upside down, you would see that those are all division signs. Okay? So inverted division just means I'm going to be dividing by my prime numbers that we talked about yesterday to get to an answer. The key to an answer of a prime factorization problem is that I have to remember it's a multiplication problem of primes. So I have to show whatever my primes are written as a multiplication problem. And we put them in order from least to greatest when it comes to our primes. So as I work through them, I have my own systematic way of going through to where I know that my answers are as far as I need to go, but it's also going to be in the correct order from smallest to biggest, least to greatest. Same way here, these are all the primes that are written, and they're written from least to greatest. So I'm going to show you what these means. Now please don't get stressed out about it, and it suddenly looks weird, something new, and I just can't learn math. And I promise you that is not true. I haven't had a student in over 2 decades that I have taught that I could not teach math to, except those who just didn't want to learn it. If you're willing to learn from me, I'm willing to teach you, and you'll become a much better math student. So let's look at what we're talking about. Once again, we're talking about our primes and our prime list. So the first 5 primes, 2, 3, 5, 7, 11, is really where we focus on this lesson. So on my first 5 primes, I'm going to turn this just a little bit, see if it shows up a little better. So my first 5 primes is what I generally use. Now, when you get into the higher grades, you're going to use some of these larger prime numbers when you do prime factorization. Okay, so don't think that you will never use them. But in 6th grade, very seldom do I go to the 13, the 17, or the 19 in my prime factorization problems. So as I'm working through and I focus on learning my first 5 primes, I'm telling you now, if you learned your first 5 primes, then everything becomes easier beyond this point. So 2, 3, 5, 7, 11 is what we're talking about. Notice the dot, dot, dot. That means it could be any other prime beyond that. And remember, we have primes that go beyond 100 because numbers are infinite and they go on forever. So 2, 3, 5, 7, 11. You're going to hear me say it multiple times. And if you begin to put those in your head and say them with me, in your head, or even write them down on your assignments when you're doing them, then you'll remember 2, 3, 5, 7, 11 from this point forward. So as I go through assignments and I begin to think about it, I just have to remember what that definition of prime factorization is. It's breaking down any composite number into all of its basic primes and then creating, it says the product of, it's creating a multiplication problem. That's what prime factorization is. It's a multiplication problem of primes. So what we're going to look at is we're going to start with a tree. We'll look at the inverted division also. And I think there are times that the book kind of makes things a little bit more difficult than they need to. So some of these little gray and blue boxes we don't need, and I'll tell you about them when we get there. You can just kind of put a little X on them or put a line through them and realize you don't need it, because I don't want you to get confused. What I really like about the book is they show you multiple times that there's more than one way to do a math problem. This is not wrong. It's not the way that I would do it, because it gets a little confusing for some students, but there's nothing wrong with this, okay? And I want to reassure you, if this is how you do each of your problems tonight instead of my way, which is more that way over there, then I'm fine with it. Please understand that. As long as your work's correct and you understand it, then that's fantastic, because that's my goal, is that you truly understand math and how numbers work. What they're showing you here is there are some students that they have their own way of recognizing that when I have a number with a 0 at the end of it, they see, well, it's a multiplication of 0. Okay. So one of the key parts that we talked about on previous videos, and I will always talk about in my classes, that you are following along with me. You let me lead the way, but you follow along and you're paying attention. And if you are doing that, then you have your pencil in your hand and you're ready to fill in these boxes, and that you're going to learn from me as I'm teaching and going over this. Once again, we're going to talk about our first 5 primes, 2, 3, 5, 7, 11. Always realizing we could go beyond that 11 and use other primes. So as we do it, once again, we're going to start with this way because there's nothing wrong with this way. I just feel like a more systematic way keeps you from making any possible mistakes. But I am fine with you doing it this way if you recognize that 10 times 1 something is going to be 180. So as I go through it, then I say that, well, if there's a 0 at the end and I recognize that has to be a multiplication of 10s, then what am I multiplying it by? I'm multiplying it by 18. Now they call this the tree because it kind of makes the shape of a pine tree when you step back and look at it. But each of these steps that are on the same line are indicating there's a multiplication problem going on there. So these are actually division lines when I break it down. We're saying that 10 goes into 180 how many times? Well, we already said 18, so that's what's going to go over there on that line. I cannot stop until I'm left with just primes. So when I look at 10, I know 10 is not prime according to my big chart, but also because it ends with a 0, and that's an even number, correct? So what is the smallest prime number that will go into 10? Well, that's my 2, and that's why it's listed there. 2 times what is 10 then? Because we have 2, and it's going to multiply by something to get 10. Well, 2 times 5 is 10, and that is a prime number. So when I see that, then I go to my 18, and they're saying, well, 6 goes in 18, which is a true statement. Okay, well, 6 times what is 18? Well, that's going to give me my 3. It's a prime number, so I'm good with that one. But 6 is not prime because it's even, isn't it? And if it's even, I know 2 has to go into it. And they show you that it was going to be multiplied by 3, and 2 times 3 is indeed 6. So I'm good there. Now, the part that I don't like is having to draw all these extra lines and bringing those same numbers down. Don't let that confuse you because those extra lines are not needed. They don't have to have answers that are all on a straight line. What I have to have is primes left at the end of each tree section. So I have a 2, a 5, a 2, a 3, and a 3, and those indeed are all prime numbers. So don't worry about dropping everything else down as long as I'm left with all the primes and I circle them and recognize them so that I can create my answer in the correct order. So once again, the correct order has to be to take those, create a multiplication problem, which is the answer for a prime factorization, but I put them in order from least to greatest. So I have a 2 and a 2, so there's 2 of them, a 3 and a 3, so there's 2 of those, and 1, 5. And I make sure I create the multiplication problem, 2 times 2 times 3 times 3 times 5. If I type that into my handy dandy calculator and hit equals, I will indeed get 180. Now when I go over here, notice I erased some things. So if you want to put a line on them, that is fine because if they're just those extra steps. Now it kind of changes it from looking like a nice even Christmas tree. It looks like a tree that had a big chunk cut out of it. But this is a more systematic way and it's less work also. And this, if I do it this way, I can go from my smallest prime to my largest prime and make sure that I include every one and that I don't get confused where each of my primes are left over. So when I look at prime factorization, I have my number and I write it down and then I start with 2, 3, 5, 7, 11 and I begin with 2. And I ask, will 2 go into 180 evenly? Well, it's an even number, so it definitely will. So I write it down and then I ask, well, 2 times what is 180? If I don't know, if I can't see in my mind that that's 90, I can either write the division problem on my paper or take my handy dandy calculator, type in 180 divided by 2, and I'm going to see it's 90. Okay, so 2 times 90 is 180. I know that's a prime, so I leave that sign and I build off of my 90. Is 90 an even number? It is. So I know 2 will go into it evenly. I can type it into my calculator, 90 divided by 2, and see that I multiply 2 by 45 to get 90. So I'm going for my 90 and I'm putting my 45. Now, that's no longer even, is it? So I've used the 2 as often as I can, and once I get to an odd number, I will never have to ask about 2 again. I'm done with it. My next prime is 3. So now I ask, well, will 3 go into 45? Maybe you automatically know that it will, or you can type it into your calculator, 45 divided by 3, and see that it's 15. Or you could ask, well, what is the sum of 4 plus 5? 4 plus 5 is 9, so I know 3 will definitely go into it. Since 3 will go into it, I have to know how many times, and as I said, that's 15. Well, 15 is not a prime number either. We know it 2 won't go into it because we've already used it as many times as we can, so we're going to stick with 3 until we can't use it anymore. And 3 will indeed go into 15. How many times? 5 times. And that 5 is on my first 5 primes list, 2, 3, 5, 7, 11. So I'm left with a 2, a 2, a 3, a 3, and a 5, and everything that's at the end of each branch tells me that it has to be a prime number. So I circle each of those primes, and then I look. By doing it that way, it automatically puts it in the order that my answer needs to appear into. So there's nothing wrong with this way, and if you want to do it this way, that is fine. Okay? This just eliminates some of the easy mistakes that happen by doing it that way. But either way is acceptable and will get you to a right answer. Now we're going to look at the inverted division, and there's a couple extra steps in there that I don't think you need to do because it might confuse you, and it's just extra work. And once again, I don't want you to do extra work. I just want you to do the proper work and be able to understand the math that we're doing. The inverted division then takes us from the base number, the largest number. I do my division signs upside down. So I'm asking, will a certain prime go into it? And if so, how many times? So we're dealing with 140, and notice they do it in 2 different ones. So if I start with 140, I'm going to ask, will 2 go into 140? It will. 2 will go into 140 how many times? 70, right? So they drop the 70 as the answer, the quotient, and then they put a division box around it because it's not prime. Now they said, well, I can see that that's a multiple of 10 because it ends with a 0. So 7 will go into it, and that is correct. And 7 will go into it, as we said, 10 times, so that 10 is the quotient, but it's not prime. So they built a division box around it. So from 10, we're going with our 2, 3, 5, 7, 11. Will 2 go into 10? It will, 5 times. Well, 5 goes into 10 2 times. And then this bottom box, for me, is extra steps. What it would show is that 2 goes into 2 one time, and then I'm left with a 1. But when we follow that pattern by doing that extra step, what I see generally is I have students that will circle all of these primes and the 1 and include it in their prime factorization, which ends up as a wrong answer. Because a prime or a 1 is not prime and cannot be included in prime factorization. So when I look at it though, I'm left with the 2, the 7, the 5, and the 2 as my primes, and then I have to put them in order from least to greatest. So I have 2 2s, a 5, and a 7, and I remember that it's a product answer. So it's a multiplication problem of my primes from least to greatest. 2 times 2 times 5 times 7. Now on this one over here, they said, well, a student recognized that 5 will go into it. Once again, that was the right way to do it by starting with 2. This is also a right way of doing it by starting with 5. Nothing wrong with that if that's the way you see it, as long as you use your 2, 3, 5, 7, 11 and process through it. So how many times will 5 go into 180? If I'm, 140, there we go. Well, if I take 140 divided by 5, I see that it goes in 28 times. 28 is my quotient, and then I would build my box. We're going to get to where we're building our own boxes, so it's not as confusing, but 2 will go into 28, won't it? They saw that 28 was an even number, so they said, well, 2 will go into it, and it goes into it 14 times, which was the quotient, and then they built that division box. Well, notice that they said that the answer is going to be 2. So what number will go into 14 that's not the 2? So hopefully you thought multiplication facts, and then you said 7. And 7 goes into 14 2 times. So then they're showing you that 2 will go into 2 one time. Once again, that's an extra step that here in a moment I'm going to show you that is not necessary, and I don't want it to confuse you. But if you want to stick with that, please do, and I won't count it wrong. But I do have to circle my primes, and remember that I'm just focusing on my primes, and I still have 2 2s, a 5, and a 7. Now I want to show you the way that I set it up. I went and included the division boxes that are being used. Okay? But I always, just like the tree, start with my basic prime and repeat my basic prime until I can't. And then I go to my next one and my next one. So with my 2, 3, 5, 7, 11, I always start with 2. Is 140 an even number? It is. So I know 2 is going to go into it. So 2 is going to be used. And then I ask, well, what is the answer? Or how many times does 2 go into 140? Well, it goes in 70 times. I go back to my 2 until I can't use it anymore. 2 will go into 70 because it's even. So I'm going to divide the 70 by 2. And 70 divided by 2 is what? Once again, these are just inverted division boxes. Well, 2 goes into 70 35 times. Will 2 go into it? It won't, will it? What about 3? Well, my divisibility rules is adding 3 plus 5, which is 8. Will 3 go into 8 evenly? It won't. So I know 3 is not included in this prime factorization. So my next prime is 5. 5 will go into it because it ends with a 5 or a 0. So I'm going to take 5 and divide it into 35, and I get 7. I don't do that extra step because I don't want you to get confused. But once again, if you do this extra step where you get the 1, I'm more than welcome to let you do it because it's not wrong. I just don't want you to get confused when you write your final answer. But notice when I do it, going systematically through my first 5 primes, that my primes are listed in the order that my answer has to be written in. The 2, the 5, and the 7. And that's why I always try to go from the 2 and build through my prime factorization. However, if you saw 5 went into it and that's where you started, that's fine because it is correct. If you saw that 2 went into it, but then you jumped into the 7, that's fine because that's correct. So multiple ways of doing the problem to get to the right answer. The key is that it's something that makes sense. You can repeat the process and you end up with the correct answer. 2 times 2 times 5 times 7. All right, so we're going to look at our examples that they've given us here. So in this one, they're going to say, well, I know my multiplication facts are 6 times what? Well, once again, 2, 3, 5, 7, 11. 6 times something, so I know it's 3, and it is in my list, so I know 3 is a prime number. 6, however, is not in my list, is it? It's not a prime number. So what will go into 6 evenly? Well, I have a 2, and 2 times what? Well, 2 times 3. Now notice I put an X there. Once again, that's just an extra step. If you personally prefer to bring that 3 down, I'm not going to count it wrong. More than one way to do the math problem. However, I try to eliminate anything that might cause you a mistake. And if you see a 3 here and a 3 here, it could cause you to circle both of them, which I don't want you to do. So we circle our primes where we end off, and I make sure that they're in order from least to greatest, smallest to biggest. So I take 2 times 3 times 3. Once again, the answer has to be written from least to greatest with multiplication signs, not with commas. So it's a multiplication sign, and if you want to prove yourself to be correct, then you can just do that multiplication. 2 times 3 is 6, and 6 times 3 is 18, and that is indeed what we started with. So 42. They tell you you're going to start with 2. All right, well, that's what I would normally do. 2 will go into 42 how many times? Well, 42 divided by 2 would be 21. And 21 is not an even number. So I'll never go back to my 2 on that particular problem. My next prime that they used, and I would agree, is 3. Well, 3 goes into 21 how many times? 7 times. And that's what they show you. Once again, The next step would be to divide the 7 by the 7 and see that your remainder is 1. It's an extra step, and it might confuse you at the end where you might include the 1 in your prime factorization. So I cross those out, and I don't do that step because it's not needed. But if you want to, it's not wrong. You're more than welcome to do it. But you make sure that your primes are circled, so you identify them, and then you put them in order from least to greatest as a multiplication problem. They're in order already for you, so it's going to be 2 times 3 times 7. All right, so we got some more that we're going to work through. 3, 4, and 5. So once again, as I said, I prefer the tree method, and I only use it as far as I need to go. I don't do those extra ones and drop them down and make even lines. So I'm going to start by showing my prime of 75. I know I'm going to be using my 2, 3, 5, 7, 11. I know that I'm going to be focused following along and filling out my paper so that I can look at this when I do my homework just to remind me what I'm supposed to be doing. In 75, I start with my 2. Will 2 go into 75 evenly? It won't. It's not even. How about 3? Well, 7 plus 5, 7, 8, 9, 10, 11, 12 is 12. 3 goes into it evenly. So I know 3 has to be a prime in this prime factorization. Well, once again, this row, when they're side by side, tells you there's multiplication going on in between them. So 3 times what is 75? Well, if you think about quarters, 25-cent pieces, I know 3 of those make 75 cents, so it's got to be 3 times 25. It's not prime. We already know that 2 will not go into it. How about 3? Well, 2 plus 5 is 7, and 3 doesn't go into 7 evenly, so 3 won't either. So my next prime is 5, and 5 will go into it because it ends with a 0 or a 5. So I tree from only it, because I'm done with my 3, and I'm left with 5 times 5. So 5 times 5 is the end part of my prime factorization tree. So I look at my primes. I have a 3, a 5, and a 5, and I put them in a multiplication problem from least to greatest. So I write it out as 3 times 5 times. I don't know where that answer came from, so ignore that answer. It should be 3 times 5 times 5. So when I go to the 12 then, I want to do the same thing. I know it's not a prime. It's not even in my list, even though my list stopped at 11. Will 2 go into it? Is it an even number? 2 does go into it. 2 goes into it 6 times, because 2 times 6 is 12. 6 is not even, so just like before, I'm going to treat it, and I know that 2 goes into 6 3 times. I'm left with my primes of 2, 2, and 3, so those are what my multiplication problem becomes. So I have 2 times 3. Make sure you have multiplication signs and not commas. It's a common mistake. It has to be a multiplication problem. And then I have 65. 65, I'm going to tree from it, but 65 is not even, so I don't even have to think about my 2. But what about my 3? Well, 6 plus 5 is 11. 3 doesn't go into it, does it? So we have to go to our 5, which is our next prime. 5 does go into 65 because it ends with a 5 or a 0. Well, how many times? Because once again, this is a multiplication when it's on the same line. 5 times what is 65? Well, when I do that division, if I type it into my handy-dandy calculator, if I don't know it off the top of my head, 65 divided by 5 is 13. And even though it's not on my list, on my original chart of primes, 13 is the next prime after 11. So my prime factorization is just those 2 math problems. 2 numbers. 5 times 13. Now, look at what this says. This says in my directions, write the number whose prime factorization is given. So they've given you the prime factorization, and all you have to do is write the answer. There's no work to show here. It's all written out already for you. You just have to do it on your handy-dandy calculator and make sure you do it correctly. The only problem that I've had on these is they accidentally only type in 2 2s, or maybe they type in 4 2s when they're multiplying. So just be precise and don't be in a rush. Type it in as 2 times 2 times 2 times 7 equals, and you're going to see that it's equal to 56. Then I go to 7 and I type it into my handy dandy calculator. 2 times 2 times 5 equals, and I'm going to get 100. So the prime factorization of 100 is 2 times 2 times 5 times 5. And then on number 8, I take 2 times 2 times 2 times 2 times 3 equals, and I'm going to see that that's 144. So we're going to skip 9 through 11, or 9 through 14, excuse me, just in case you are having questions or struggling. You'll bring me a extra sheet of paper because there's no room to work these out on, and we'll process through these. And I will do the division stair step with you, the inversion division with you, or I'll do the tree with you, whichever you prefer and you want to do and you find easier. But that leaves everyone else focused on their homework. So on page 15, you're going to do 2 through 9. Now notice my extra note that I have up here. On number 9, it says give 2. You only have to give 1. And either one is correct, so 1 will just work. And then on 16, 1 and 2 is doing the same lesson that we just did. And then 3, 4, 5, and 6 is going to be a review over the previous 2 lessons. So as you're working through it, if you have questions, please come and ask. If not, then there should be enough time for you to get your assignment done.